Hello everyone. So today we're going to talk about summation notation. So we briefly saw summation notation back when I introduced to you formally what an integral was. And so remember I told you that the definite integral was the limit as n goes to infinity of this Riemann sum, the left Riemann sum or the right Riemann sum. And expressing the left and right Riemann sums, I had shown you could use this notation called summation notation. So now we're just going to look at it a little bit deeper. So this big looking E, we call this sigma, okay, and it's a Greek uppercase letter. And the summation sign basically just instructs us to sum the elements of the sequence. So in this picture, I sort of just have a breakdown. When you look at this, we have that this is the sum from I equals 1 to n of xi. So the I equals 1, that's the index. The I is the index, and 1 is telling us the starting point. So when you see this at the bottom, I equals 1, sometimes you might see k equals 1. That letter there is the index, and the number corresponding is where you start, and then the top is where you end. Okay, and of course, like you know, the big E means sum. And then xi is telling us the terms. Okay, so looking at an actual example, looking back now at what I was describing, what this really means is that you take the first term, where I is 1, and instead of writing I write x1. So that's how you see the x1 there. Plus, because now I'm summing to the second term, now I go to the next whole number, which is 2, and I plug in 2 for I, which is x2. Then I go to the next whole number, which is 3, and plug in 3 for I, so now I have plus x3, and so on and so forth, all the way until my ending point, which is n. Okay. So, and then here I also just have another example. So you saw how in the second example, we start at 3 instead of 1, so that's why my first term says x sub 3 instead of x sub 1. And I only go all the way to 10 because here's my ending point, here's my starting point. So now let's do this example out in practice 1. It says find the sum of the terms described below. So what this means is I need to start with 3 when I'm replacing in for I, and then I need to end with 7. So I'm summing from 3 to 7 of I squared. So I'm going to plug in 3 for I. So I should get 3 squared plus the next term. So now I go to the next whole number, which is 4 squared, plus the next whole number, which is 5 squared, plus 6 squared, plus, and now I stop at 7 squared because I need to end at 7. So this gives me 9 plus 16 plus 25 plus 36 plus 49. And then I'm going to add up all these numbers together. So I should get 50 plus 36 plus 49, which is 86 plus 49, which is 135.